Okay, I think my microphone is working and this is the first try, so that's good. I know my first hour I talked to about how I recorded this whole video on Tuesday and then none of it had audio. So I was very upset with my computer. But I think that we're good now. Okay, so we were talking on Monday about these 4 rock samples. And today we're going to be making observations about these samples. Study on them will help us learn how to collect evidence from these types of samples. We have done something similar to this, so this should be pretty normal for you. You should know what to expect. We do have a few vocabulary words before we get into it. Our first vocabulary word is matter. Matter is anything that has mass and takes up space. So gas, liquids, and solids are made out of matter. Solids make sense, right? If I took a blanket and I put it on a scale to weigh it, it would have mass and it takes up space. It can take up space when you put it on. It can take up space when it's on the floor, right? It is doing both of those things. Liquids has mass. Think about how heavy your water bottle can get when you fill it all the way up to the top. And it also takes up space because it takes up that space in the water bottle when you fill it. Gas is a little trickier. Gas does have mass, but it's very, very, very small. And it also does take up space. We can't see it, but you know that it's around you because if it didn't take up space, you wouldn't have any oxygen to breathe in. So we know that gas takes up space because we can breathe it in, and therefore we know that it is already around us. It is taking up the space in the air around us. In my classroom, there's all of the oxygen in there. Think about, this is going to sound so silly, but think about if you fart, okay, that fart is taking up space in the air, and that fart is a gas. So these 3, gas, liquid, and solids, all are made out of matter. Our second vocabulary word is a sample. This is a small part of what is meant to show that is meant to show what the whole is like. So, I would love to know what you think a sample is, or can you give me an example of a sample? That kind of rhymes. Example of a sample. When most students see this word, they think of Costco or Sam's Club because they give out those samples in order to show what the small part of the whole product is. So if they give out a taste of, I was just at Sam's Club and they were just handing out cheesecake bites. So they're just giving out a small bit of cheesecake in order to show what the whole cheesecake tastes like. Man, was it delicious. Another sample would be like a paint sample. A paint sample could help those that are shopping for paint in order to figure out what that color of paint looks like before they buy a whole gallon of it. The rocks that we have looked at are also samples because they are a small part of a whole rock formation, which is actually our next vocabulary word. A rock formation is a region of rock that is formed together as a single rock type. So, for example, here is a picture. Okay, this is a rock formation. The top that is a different color, dark brown, is going to be one rock formation. The bottom that is the lighter color is going to be another rock formation. There are these 2 different colors because of the minerals that are in them. Those minerals can cause rock formations to change colors and can be different types of rock on the bottom comparative to the top. If we took, see all these rocks on the side or some over here? If we took one of these rocks from this rock formation, that would be a sample of the rock formation. Another example is this canyon that is between, it looks like kind of like the Grand Canyon, but not quite. But it's a rock formation, and the different colors is going to be in showing us different rock formations. So just because it's one huge rock does not mean that we just have one rock type. We have one color of rock down here, we have another color of rock in the middle, and then our top is also a different color of rock. So in this glob, I guess I'm going to call it, glob right in front of us, we have 3 different rock types. You can tell that because of the colors. Now, it could have more than 3, right? But that's just what I can see based on this picture. Another rock formation that you guys probably know of, and some of you may have been there, is the Grand Canyon. This is a rock formation, and the Grand Canyon is specifically famous for having layers of rock. So, as you'll see in this picture, we have a top layer of rock that's a different color than our middle layer and our bottom pinkish layer. All of these layers of rock are their own rock formations because they have different minerals. And if we took a piece of rock from anywhere in the Grand Canyon, it would be a sample of where that rock formation was. Now what you're going to be doing is you're going to work in groups, aka the person next to you, in order to make your observation of the samples. Remember, you are being polite and you are asking to see the rocks if they are using them. There's 4 rocks between the 2 of you, so I don't think that there should be any issues on sharing these rocks. But you can use a magnifying glass if you would like to, or you can just use your eyes. I need 5 observations of each rock. And while you do this, you're going to be observing and recording in Amplify. So on Amplify, well, it's actually in my Google Classroom. You have to go to Google Classroom and you have to click on rock observations. And it's going to take you to something that looks like this. It has 4 boxes. This is where you put your 5 observations for each rock sample. So there should be 5 here, there should be 5 here, there should be 5 here, and there should be 5 here. Okay, what I like to do is I like to put 1, and then I hit the enter key, and then I put the 2nd, and then I hit the enter key, then I put the 3rd, then I hit the 4th, then I put the 5th. Okay, hitting enter will just make it go down a line. So that is an option if you'd like to do that. When you get done, please click this hand in button. I cannot grade it unless you click that hand in button, so I will mark it missing unless you do that. Lastly, I would like to talk about observations and what they should look like. So we have 2 observations on the left. They're both describing an object. So the top one says that it's a solid and it's transparent. Well, think of what is a solid and is transparent. I would like to know what you think is the object just based on this. Okay. Number 2 says that it is transparent, has a circular shape, has line markings on the side with numbers, and is made of a hard, solid material. Now I'm curious if anyone can guess what this material or, object is. Regardless of if you got the object, which description would help you identify the object more easily? 1 or 2? 2 has so much more information about the rock. This is what I said about making sure that I understand what you're talking about. If you just say, it looks like a grape, how does it look like a grape? Give me more. Okay, is it green? Is the rock green? Is it purple? If not, maybe you're talking about the shape. Okay, maybe the rock is smooth like a grape. Okay, add in information, please. This is the last thing that I would like you to keep in mind when you do these observations. I want you to think in your head, can someone identify each rock by only using My observations that I write down. So the 5 observations, if I said it is purple, it is round, it is, squishy, it is, we'll go with those 3. And that can be many things, right? It could be a thing of yarn, okay? It could be a purple yarn. It could be a grape. It could be a squishy, like one of your ice cubes that you guys have, though that squishy ice cube, but purple. Okay, there's so many things that could be. So think about if I'm going to be able to identify which rock you're talking about by only using your observations. Lastly, before you move on to the to amplify into making your observations, we're going to watch this video, and then I will leave you to make your observations.
There's only one place you tend to get mountains, where 2 tectonic plates meet. Essentially, 2 plates smash together and push rock up to form a line of mountains along the boundary. And sure, there's more to it, but that's basically the story, which makes it really irritating that there's a mountain range in the wrong place. North America's Rocky Mountains are located smack in the middle of the continent, hundreds of kilometers away from the nearest plate boundary at the edge of the Pacific Ocean. And it turns out the question of why the Rocky Mountains formed where they did is actually a pretty hot debate among geologists. So let's take a look at what we know and what's still a mystery about why one of the world's most iconic mountain ranges is where it is. The Rocky Mountains we see today started ascending around 125 million years ago during the severe orogeny. An orogeny is just what geologists call a mountain building event. The severe orogeny stretched all the way from present-day Alaska to Mexico. It folded and fractured layers of sedimentary rocks, bunching them up on themselves to start building mountains. But it wasn't the only game in town. The subject of the most debate is the Laramide orogeny, which was largely responsible for the range in the United States. Instead of folding layers of sediment, these mountains were built by breaking and piling up hard rock like granite. This mainly occurred a little later, between 80 and 55 million years ago. Back then, the seafloor of the Eastern Pacific was made up of 2 oceanic plates, and both were subducting beneath North America, sliding under the continental plate and into the mantle. On the other side of the continent, the Atlantic Ocean was in the process of opening, so that oceanic plate was pushing North America towards the west. Despite the Rockies being up to 1,500 kilometers from the Pacific plate boundary, geologists do agree that this subduction zone is responsible for building the mountains. What they argue over is how it could have happened so darn far from the coast. But they have come up with 4 hypotheses. The first is retroarc thrusting, the idea that the North American plate was pushing so hard to the west that instead of the oceanic plate slipping smoothly beneath the continent, it got stuck. And all that stress caused the continent to crumple like a car wreck. But this begs the question of what did the pushing? One idea is that it could have been the seafloor spreading from the Atlantic Ocean on the other side of the continent. But when we look at the rates of spreading recorded in the Atlantic seafloor, we don't see much evidence for it being in such a hurry. And regardless of where the push came from, for this idea to work, the section of North America west of the Rockies would need to be strong enough to withstand the collision and pass the stress inland. Which it's not. At least it doesn't seem like it. There are faults out west, meaning cracks where the crust is weak. A bunch of these are older than the Rockies, so why wouldn't the crumpling have happened there? So the second idea is orogenic float. Maybe those faults we mentioned detached a section of the lower crust from the rest of the continent. Then it could float, essentially unattached. Then the force of the Pacific seafloor subducting could skip this section and get passed inland to the east. But in that case, where is this detached section of crust? It would have eventually smashed against the Rockies, and we don't really see any evidence of that happening at the right time. So the third idea is a transpressional collision. Transpression is just a combination of the words transform and compression. It means a fault that is both moving side to side and together at the same time. The idea is that a long north-south transpressional fault existed where the Rockies are today. North America was essentially split in 2, the main continent to the east and a thin ribbon continent to the west. The magnetic signature in some of the rocks near the Canadian Rockies indicate they formed thousands of kilometers to the south. So that's strong evidence for this idea. The transform part of the fault would have moved the ribbon continent northwards, including those rocks, and the compression part would have pushed it up and over the main North American plate to build the mountains. The only catch is, if a ribbon continent collided with the rest of North America, geologists expect at one point there would have been an ocean between the two. And we just don't see the kind of volcanic evidence that would be left over from an oceanic plate subducting before this collision. See, oceanic plates have a ton of water in them, which gets released under heat and pressure. Water lowers the melting point of the surrounding rocks and creates magma. This means a subducting plate tends to create volcanoes. In this case, they could actually end up east of the Rockies in what we call the Great Plains, which we call that because of a notable lack of volcanoes and other volcano-shaped objects. This is also relevant for the final idea, flat slab subduction. While there's still a ton of debate, this is the most popular of the four. Normally, subducting plates plunge into the mantle at a steep angle, which means they quickly get deep enough to release their water and form magma. But if an oceanic plate was younger and hotter, it could be more buoyant and not sink as easily. So the idea here is that the subducting plate slid along underneath North America for over 700 kilometers before finally getting deep enough to produce magma. That melted rock would go on to make up the core of the Rockies, just much further inland than expected. What's more, scraping one plate under another for that long would have transferred stress to the same area, again with the crumpling. But even though this is the most popular hypothesis, it still has a problem of its own. There are remnants of ancient volcanoes to the west of the Rockies in both Canada and Mexico. So it seems like that's where the subducting plate was producing magma, not where this hypothesis would expect. So the truth is, we don't know the definitive answer here yet, and none of these models have been able to fully explain every line of evidence. Some studies conclude that we need a combination of these different mechanisms to explain what happened. For example, it could be that one hypothesis was responsible for the first mountains built and another took over later. Or it could be that different mechanisms were at play in different sections of the mountain range we see today. Some researchers have suggested that a corridor of flat slab subduction could have been responsible for the mountains in the central United States. It just doesn't explain the mountains to the north and south. What is clear is that the Earth doesn't always do what we expect it to, and reconstructing the events that created what we see today can be pretty challenging. But at least it does make for some good skiing. If you enjoyed this episode, you're probably the kind of person who likes rocks. And so, to all the rock enjoyers out there, I have a thought for you to ponder. Imagine if an incredibly cool rock showed up at your door. And what if that happened again the next month? And the one after? Well, I don't want to say too much, so I'll leave you with that, lovers of shiny things, and I'll tell you, you should look out for our live premiere on October 2nd. Until then, thanks for watching.
I don't know about you guys, but more rocks and more rocks at my door, I think that would be the best day of my life. Anyways, okay, so you are going to go to my Google Classroom. You're going to click on rock observations. You're going to go to this beautiful table. You're going to share your rocks very nicely with the person that you're sitting next to, and using your manners if you want to look at their rock. Please make sure that you keep the rocks on the numbers that they are already on, so that my classes after you all can make sure that they're recording their observations for the correct rock. Okay. If you have any questions, please make sure that you raise your hand and be polite, whether it's to me or to our guest that is taking over for me in the morning. Okay. Good luck. Bye. Oh no, I can't end it, y'all. Oh, duh.